Hello everyone, I hope everyone is doing really great. So in this class we will learn about the formation of the partial differential equations, right? So how we can form a partial differential equation. So you can see that I have written that the formation of partial differential equation can be made via two methods. One is by the elimination of the arbitrary constants that are present in the equation and by elimination of the arbitrary functions. So how we are going to deal with that, I will discuss in this session, and I will also solve three different problems for you to understand this concept properly as well as to use this in your examination. So see, in this problem, you can see that the question says you to form a partial differential equation by the elimination of the arbitrary constants, where you have got an equation that says that 2z equals to x square by a square plus y square by b square. So in this equation, a and b, they are your arbitrary constants. In this equation you have got a, b and c as your arbitrary constant, and in this equation you have got a, b and c as your arbitrary constants. So before solving these three problems, I want to talk about some very basics so that you can understand it more properly and clearly, and so that you can have a very basic idea and clear concept about the partial differential equations. So here are the key points or the basic points. So a differential equation containing one or more partial derivatives can be called a partial differential equation. Okay, so partial differentiation occurs only when there are at least two independent variables. You need to have at least two independent variables. You cannot deal with one independent variable, because if you deal with one independent variable, for example, see in my case, suppose there is a function of f of x that is suppose 3x square. This is the function f of x equals to 3x square. So now if I want to differentiate this equation, so I'm differentiating f of x with respect to x. I'm differentiating this equation. So what I am going to get, I'm going to get 3 into 2 into x, right? As we know that ddx of x to the power n is equals to n x to the power n minus 1. So this is the very basic differential equation formula. Well, I have just used that in this case. 3 remains as it is and 2 comes forward, and you have got 2 minus 1 here, 2 minus 1. So you will get the equation that I have written, right? 3 into 2 minus x, so it will become 6x. So because there is only one independent constant, independent variable, I'm sorry, there is only one independent variable. If you differentiate it, it will become a complete differentiation. It will not become a partial differentiation. The condition for it to become a partial differentiation is this, that it needs to have at least two independent variables. So I am writing it down here. So you have given that z is a function of x as well as y, right? So now if I differentiated this equation ddx, okay, and this is also equal to x square into y, as I have written here, right? I am just solving that. So now see that if as I am differentiating this equation with respect to x, I will only operate on x and treat y as a constant. So it will become 2xy, as I have only differentiated x square, and y remains as it is. Okay, y remained as it is. And if I differentiate the equation with respect to y, what I'm gonna end up getting is simply x square, because the differentiation of y with respect to y is simply 1. All right, so now I am going to discuss about the third point, where it says that the order of a partial differential equation is the order of the highest order partial derivative. So here the highest order partial derivative is what? 1. So the order of this partial differential equation is simply 1. And what is the order of this equation? You can see that the highest order of the partial derivative present in the equation is 2. So this is also going to be 2. The order of this partial differential equation is also 2. So now see that the degree of a partial derivative equation is the power of the highest order, and the partial derivatives of, okay, they are very important. See, I think there are some mistakes, don't look at them. So dz dx, this is going to be represented with p. Dz dy, this can be represented with q, and then d square z divided by d square z by dx square. So this is going to be r. Okay, after that you have got d square z dx dy. This is going to be equal to s small s, and d square z over dy square, this can be represented with t as well. So they are just convention. You can write p in place of dz dx. You can write q in place of dz dy, so on. Okay, you can replace this with s. You can replace this with t as well as you can replace this with r. Okay, so there are some conventional representations you can see. Okay, so after that I'm going to move forward to solve the question number 1. So see, I have already discussed that the arbitrary constants in this case are a and b. So what I am given, I will write that, and I will simply differentiate. I will need to remove a and b from here. Somehow I just need to remove a and b here. See, if I differentiate this equation, if I just simply differentiate this equation with respect to x, then I will get rid of this part. I will get rid of this part because this part has no x term. There is no independent variable x. So I cannot operate in that part, and this part will be treated as a constant. And you know that the differentiation of a constant is always 0. So in that case, I will be having anything that will have a. I mean, I can get the value of a as a form of something. And then if I differentiate the same equation with respect to y, what I'll get? See, if I differentiate this equation with respect to y, I will get rid of this term. I'll get rid of this term, and this term will become 0. Why? Because in this term, you don't have any y. You don't have any independent variable y. So the differentiation of this part with respect to y will become 0. So I will only be left with this part, and from here I can find the value of b square or something, and then I can just replace, and I can get rid of a and b very easily, right? So see that I have written the differentiation of equation number 1 with respect to x. So see, 2 will remain as it is, and z, as you know that z is a function of x and y both, so it is not a constant yet. So I am just differentiating that equation with x, dz dx. I will write that, right? I'll write simply that 2 into the differentiation of x is dz dx, and the differentiation of x square divided by a square is what? The differentiation of x square is 2x, and a square will remain as it is. And the differentiation of this part, y square by b square, with respect to x is 0, as I have written here, you can see, right? So from here, I can find the value of what I have just cancelled 2 from both of the sides. Then I'm left with this part dz dx equal to x over a square. And from here, I can find the value of 1 by a square, and x will be sent to that part, sent to the left side of the equation. So I will be left with 1 by a square equal to 1 by x into dz dx. Same, I have just done this, that I have differentiated this equation with respect to y in order to get rid of this part, right? So then I will be able to find the value of b in order to put that again in this equation to get the partial differential equation, right? And in that equation, I have completely eliminated the arbitrary constants. You can see that in my answer, this is my answer now. So in this answer, you can see that there is no constant, there is no arbitrary constant, right? How I have done that? I have done that using very simple method. I have at first differentiated that equation with respect to x, then I have differentiated the very same equation with respect to y. So if I differentiate that equation with y, see what will happen, that I will be left with, see that if I differentiate with this equation with respect to y, I will get 2 as it is, and z will be differentiated with respect to y. So dz dy, and this term will be 0 because this is a constant. If I am differentiating the equation with respect to y, because there is no independent variable y in this case, right? So I hope that you have got this already. And then the differentiation of y square by b square is 2y over b square. So from here I have just cancelled 2 from both of the sides, and then I have found the value of 1 by b square equals to 1 by y dz dy. And from then after that I have done this, that I have replaced the value of 1 by a square, see, just with the value that I have got. And then I have already shown you that you can write dz dx as p. P is written as in place of dz dx, and dz dy is written as q. and 1 x is left here, right? From here as well, 1 y is left. So I hope that you have got this problem very easily. Now we move to the second problem. So in this problem, see, I hope you can see it very clearly that x minus a whole square plus y minus b whole square plus z square is equals to c square. So in this case, what are my variable? X is my variable, y is my variable, right? So I can easily differentiate that with respect to x. If I differentiate the equation with respect to x, what I will get? See, x minus a whole square, no? X minus a whole square. So you need to differentiate it with respect to x. So ddx. I'm just giving you an example. Suppose this is your whole term as x. Suppose this is your x. So this will become 2 into x minus a, and you had assumed that this part is x. That's why you have treated it like x to the power n. That will become n x to the power n minus 1. The differentiation of this part. This is the chain rule, nothing else. Just the chain rule being applied here. So x minus a, you have treated it, but is it really x? Was it really x? No, it was x minus a. So you differentiate it again with respect to x, and then you multiply it. So here x is x minus a. If you just differentiate it with respect to x, what we will get? You will get only 1, right? Because ddx of x is 1 and ddx of a is 0. So you will get only 1. So 1 is being multiplied with this, right? So here I have just escaped that. It can be written that you have got 2 into x minus a into 1, and then y minus b whole square. Okay, y minus b whole square. Here you have got y and b, and there is no x. There is no x in this entire term. There is no x in this entire term. So I will treat it as a constant because I'm differentiating with respect to x, and I don't see any x here. So I will treat it as x. Sorry, I will treat it as a constant, and the differentiation of this term with respect to x is simply 0. So I don't write anything here. And then I write that the differentiation of z square, the differentiation of z square with respect to what? With respect to x. What is it going to be? Because I know that z is a function of x and y both. So I cannot treat it as a constant. So differentiation of z square is going to be, the differentiation of z square is going to be, suppose, okay, differentiation of z square is going to be 2z and dz dx. Because a chain rule is being again applied here, right? So after that, c square, okay, c square is a constant definitely, so this is going to be 0, the differentiation of that part. And after that, I have just done nothing but calculated this like this, that 2 from both of the sides are being cancelled, and x minus a is equals to minus zp, because dz dx can also be written as, or can also be replaced as p, right? Okay, so after that, I have differentiated the equation with respect to y, and I have got this part, y minus b equal to minus z cube. Same, because when you will differentiate with respect to y, in that case you will treat this part as a constant and it will become 0. So that's why you don't see anything here. And then if you just differentiate this part will become 2 into y minus b, and again you have differentiated this part, y minus b, and you have got only 1. That is the chain rule, nothing but the chain rule. So if you have any issue with this chain rule and you are not being able to understand this part, so you should consider revisiting this part so that you can understand it very clearly and easily, right? So equation 1 will become, I will just replace x minus a with minus zp, and y minus b with minus z cube, and I will just get this, and this will be my required partial differential equation. But you can see that in this equation that I have got, I don't have any arbitrary constant. So this is my result, as they have told me to form a partial differential equation by the elimination process of of the removal of the elimination process of the arbitrary constant. So I've got this equation, and in this equation I don't see any constant. So this is my result, right? This is my result. This part is my result. After that, I move to solve the next problem. So in this problem, you can see that I have got ax plus y, bx minus y, a bt plus c. Here t is also my operator, or you can see that my independent variable t is also my independent variable. Okay, so in this case I will differentiate partially the equation number one. In this case this is equation number one with respect to x, y and t. Okay, so if I just do that, when I am differentiating with respect to x, what I will get, see that I will get a from here and b from here. If you just a into x plus y plus b into x minus y plus ab, sorry, I think that's out of the screen, plus ab, and then abt plus c. Okay, so I will need to differentiate this equation with respect to x. So for that, you can see that here it will be ax, here it will be bx, here it will be abt plus a plus c. So here I will only get a, here I will only get b, right? And all the rest other terms are going to be zero because they are constant. So I will get a plus b equals to p, because dz dx is already p, because here it is z. So if it is being differentiated with respect to x, I will get dz dx. Same goes for this and this as well. So after that I have just replaced the value, and I have just done one thing, that I have applied this formula, which is a plus b whole square equal minus a plus b whole square minus a minus b whole square is equals to 4ab. We have studied in the smaller classes. I have just applied that, and as I have got a plus b, a minus b and ab, I can very easily connect them to get the required partial differential equation. You can see that and you will very easily understand it. So that's it for today, and thank you for watching. And in the upcoming classes, we will also solve different problems of this chapter, where I will also discuss about the elimination of the arbitrary function and its numericals.